Good evening all. Myself, Sanil Kumar BG, Assistant Professor in Mechanical Engineering. Welcome to the next session of online ATAL-FDP on Green Energy Solutions, Building a Sustainable Carbon Neutral World, conducted by the Department of Mechanical Engineering, College of Engineering, Matakara. Our next session is Green Geotechnics by Dr. Divya PV, Associate Professor, Department of Civil Engineering, IIT, Palakkad. She has been working with IIT since 2017. She received her PhD in Geotechnical Engineering from IIT Bombay in 2012. Her research interests includes geosynthesis and reinforced soil structures and ground improvement. She is a Technical Advisory Committee member of Implementation of New Technologies for Transportation Projects by Government of Kerala. I warmly welcome Dr. Divya PV to our current section. Thank you.
Yeah, thank you so much for the nice introduction.
Thank you, ma'am.
So I will share my screen.
Yeah, ma'am.
So my presentation is about green geotechnics. So the name green geotechnics refers to the application of sustainable and environmental friendly practices in the field of geotechnical engineering. So my talk will be slightly deviating from others because I belong to the field of geotechnical engineering. So that's the reason why I made my presentation in a very brief and general manner, so that you will be able to understand what I am going to talk about. So in geotechnical engineering, what all are the move towards sustainability, and what all are the move towards the smart materials? So that's what I am going to talk in this session. And we all know the call for the sustainability. And the role of a geotechnical engineer to ensure sustainability in various applications is very important. And I believe that not only a geotechnical engineer, all of us as an engineer will be able to positively contribute to the society. So my specialization is actually in the field of reinforced soil and ground improvement techniques, which means usually in most of the civil engineering construction, foundation is very important, and the properties of the subsoil is also very important. And especially in Kerala, like if we consider the area like Alappuzha, Cochin and all, we know that the soil is mostly soft clay. So it's very difficult to construct on top of it. So we need to improve the ground. So in my presentation, I will speak about some of the ground improvement techniques that can be used for soil improvement, and how the green geotechnics can play a big role in that. Another area which I focus on, the sustainable geomaterials. That is, for most of the geotechnical engineering application, we use sand, gravel, rock, which is natural aggregates. And we know that nowadays this natural materials are depleting in nature. So how we make use of waste material instead of natural aggregates? Now, other areas include geosynthetics, reinforced soil structure. I'm sure, I don't know like how many of you are familiar with this type of structures, but I'm sure all of you might have seen this type of structure, which I think in a couple of slides I will explain about the geosynthetic reinforced soil structure and how green geotechnics can play a big role. And we are not very new to the rainfall triggered slope failures, landslides, because we know in the year 2018, 19, 20, during the monsoon season, we were hit by major landslide events, and then we struggled a lot with the floods and unexpected climate changes. So how we can tackle these issues by adopting sustainable practices? That's what I am trying to focus in this particular lecture. So coming to the first one, because I told you I am not going to talk in detail about the geotechnical engineering, which would be pretty boring for all of you. So a geosynthetic reinforced soil structure, even though you might have not heard about the name, I'm sure this structure is very familiar to you, because in most of the highways we might have seen these flyovers. So the flyovers usually require an approach road. So it can be constructed by using an approach embankment. So what you are seeing here as a wall, that is called as reinforced soil wall, or sometimes mechanically stabilized earth wall. So if we are going to use the conventional practices like a concrete structure, we need huge quantity of concrete, and also it's going to be very massive structure. We know that the concrete is also not a very sustainable option, though it's very, inevitable for civil engineers. In most of the structures we do use, but here the approach is to use a mechanically stabilized earth wall, where the majority of the fill will be using the locally available soil, and we can reinforce this structure by providing geogrids or synthetic materials. That's what we usually call as a geosynthetic reinforced soil structure. So using this geosynthetic reinforced soil structure, we will be able to avoid huge or massive concrete structure. So that's what we usually adopt in highways. And this particular photo is from a site near Palakkad, and I think in most of the places now we do have these type of structures. Now, if we look into these structures, for constructing about a 10-meter height of the wall for 1 kilometer stretch, we need a huge quantity of backfill. It's usually more than about 1 lakh cubic meters. And there are many places where NHAI is, planning to have new roads, or there is a doubling of the existing highways. So we need huge quantity of soil. Okay, so as I told you, for 1 kilometer, if we need 1 lakh cubic meters of soil, imagine how much quantity of soil is required. And it's not only any soil cannot be used. There are stringent guidelines. So what you are seeing here is IRC-SP 102 is the standard for Indian Road Congress, and then you have FHW and CMA, like that. You have several standards for the construction of these reinforced soil structures. And these standards mandate, the particle size, gradation limits, and the properties of the soil, shear strength characteristics. So there are stringent guidelines about the selection of materials. So most of the guide says the percentage of fines, that is less than 75 micron, should be limited to 0 to 15%. That means we should use sand or gravel. The main component should be sand and gravel in the backfill. So we don't have sand or gravel nowadays. We know that sand mining is restricted, and then gravel also. These type of good aggregates we don't have. River sand is not there, right? So we should have an alternate. So what we try to use is the construction and demolition waste. The construction and demolition waste is something which we can extract from the construction industry waste, which will include the concrete waste, brick, aggregate waste. So we tried to collect different fractions of this construction and demolition waste. And then, yes, any waste material cannot be used for engineering applications. We know that, right? So a detailed characterization is required. So we have collected the material, we have separated the fractions, and then we have taken these fractions for various engineering characterization, including the direct shear test, triaxial test, and then the same characterization. So we could see that the construction and demolition waste material, especially the sand and gravel fraction, can be used for this backfilling application, so that we can save good quantity of this sand and gravel. Why is it sustainable? Because we do have a lot of environmental benefits. One is the waste reduction. So if we are not using the C&D waste, it's going to be ultimately dumped into the landfill. So landfill is not at all a sustainable option. We know that, right? It's not a good idea to utilize our land for dumping the waste. So it will lead to the waste reduction. And another important point is the resource conservation. That is, if good quantity of materials are not available, we need to extract the natural materials like aggregates, soil, sand, gravel. So utilization of this type of material will help in lowering the carbon footprint. Another important benefit is the economical benefits, that is significant cost saving. Why? Because it lower the construction cost by replacing the natural materials with the recycled material. And also, this will also give some good opportunities for the waste management industries. And nowadays, there are some few construction and demolition waste industries. I think they are, converting this material into the payment tiles and all these things. So that is also a good option for revenue generation. And it will also lead to economic benefit by reducing the landfill tipping fee for the disposal of the construction and demolition waste. Now, apart from this, the material, it's not only like economically beneficial, it should have good engineering properties. So for this MSC wall application, we need a very good shear strength. The material should be able to carry load, settlement should be less. So we have evaluated all these properties, and then we could find that these materials sometimes, it depends on the source. The one which is derived from the concrete based waste, it has a very good strength, and sometimes more than the natural aggregates. And also we could see that is according to the regulatory compliance, it aligns with the sustainability goals. So we can consider this C&D applications as a sustainable option because of these factors. One is, reduces the landfilling, and then resource conservation, and we do have good energy savings, carbon emission reduction, and also economic benefits. So that was one a good project, and it was a project which is funded by Department of Science and Technology, and it's going very well. And then we are in the stage of full-scale testing, that is by constructing MSC wall by using construction and demolition waste, and then evaluating the performance. Now, apart from the highway MSC wall, we could see that because the application point of view, if we see the slopes, embankments, and then the reinforced embankments. So these all are very similar in nature. So we could see that the construction and demolition waste can also be used in the drainage layers, in the filters, and also as the reinforced fill backfills. Okay, and how we could confirm the stability aspect. So for that we have done a model test, and which was heavily instrumented by using earth pressure cell, suction sensors, LVDTs, and also we could see that the lateral deformation, which is very important aspect in the case of highway MSC wall, especially. There is, stringent guidelines regarding the deformation. What is the permitted deformation of the highway MSC wall? So we could see that the horizontal deformation of the facing of MSC wall is much lesser than when we are using the conventional backfill material. So which confirm the application of this material for the reinforced or structural backfills. Now, another important application which we could see is in the application of stone columns. So stone columns are usually, used for stabilizing clay. So ideally, we use pile foundations, which is made of concrete, which is considered as a deep foundation. Now the alternate is to improve the ground so that it will be able to take more load. Okay. So this is particularly for the ground improvement application. So what I was talking about, how we can improve the ground. That is, instead of using the deep pile foundation, what we can do is we can insert stone columns. Again, we need the natural aggregates. We need gravel or stone material for that. So what we have done is we checked whether we will be able to replace the conventional material with this construction and demolition waste. So we could see that the performance of stone column when we use construction and demolition waste is very similar to that of natural aggregates. So I have not included a lot of results in this because I thought the audience may not be from the geotechnical engineering field. So those who are interested in this application can refer to this particular paper which I have shown here, the construction and demolition waste as a valuable resource for geosynthetic NK stone column. So this is published in AACE journal. And another important application where we use chemical stabilizer is in the admixture stabilizations. So this is very widely used, especially in many places and many sites in Kerala. We make use of lime stabilization. Lime, we all know, like it's CaO, calcium oxide. In the hydrated form, it's calcium hydroxide. So we use this lime for stabilizing soft clays. The soft clay, especially the marine clay, or in many places in Cochin, we do have deep soil deposits of about 60 meters. And it's very difficult for having construction on top of such very soft clay. In Kuttanad, Alappuzha region, we do have Kuttanad clay, which is very notorious. So what we geotechnical engineers do is add lime. If the soil is of very 1 meter, 2 meter thickness, we do simply mix lime with soil, and the mechanism of improvement is by means of chemical reaction. That is, the first quicklime will take the water which is there in the soil and form hydrated lime, that is calcium oxide plus H2O will make calcium hydroxide, and then lots of heat is generated in that. Thereafter, cation exchange will take place, because usually, we know that in lime we do have Ca2 plus, and the lime will increase the pH of the soil, and it will replace the weak ions in the soil. Usually in the clay soil contain Na plus sodium ions that will be replaced with calcium ions, which will lead to the flocculation and aggregation of the soil particle, which will improve overall improvement in the soil properties. The plasticity characteristics will be improved. And also there will be pozzolanic reaction, that is in the presence of reactive silica and alumina, which is there in the clay. Lime will react to form cementitious compounds like calcium silicate hydrate, that is CSH, and CaH, which is really responsible for the strength improvement in clay type of soil, which will improve the load carrying capacity and will reduce the settlements. And overall, these are all the chemical reaction. The after effect is that, the load carrying capacity of the soil is improved. Now, as far as the physical modification is concerned, because most of the time with soft clay, it's very difficult for any construction equipment to reach the site. Not only the construction equipment, even it is very difficult for us to walk. During monsoon time, we know that, it's very difficult for us to walk into this slushy type of the soil. So if you add a little bit lime, it will dry out the wet soil, and it would be pretty easy for the vehicles to pass. Okay, so for that purpose, we do use lime. And we know that the, lime is extracted from limestone, which is again a natural resource. So it's like you are extracting the limestone, and then this limestone is processed, and then it is calcined to form the lime. That's how you make lime. Similar is the cement stabilization. Instead of lime, we use cement. We know that cement stabilization is going to be very costly and also can have, environmental impacts because of the generation of the carbon dioxide, and then, you are depleting the natural resources. So what we tried is to replace this lime by using eggshell derived lime, because the composition of eggshell is such that almost 97% is calcium carbonates and around 3 to 6% is the organic matter. So because of this high calcium carbonate content, we tried to replace the limestone by eggshell. Okay, so that was, we consider it as a sustainable and eco-friendly alternative. So the methodology we adopted was to collect the material and then, clean it, because we don't want any organic residues in it. The membrane and other things were washed, and then we dried it in sunlight, because we did it in a very small scale. And then the crushing, and then we after that we grind it, because the surface area of the material should be more, so that it will have a good reaction with the clay. Okay, so after crushing and grinding, we did calcination. So this is the methodology we adopted, the eggshell collection that was mainly done from the hostel mess or from the nearby restaurants. And then after cleaning, that was crushed and grinding. Then we calcined it. So what we could see is that the properties of eggshell derived lime was almost equivalent to that of conventional lime. And we tried to use it with the local soil. We used with one clay which is derived from Palakkad and the other one from Cochin. So we could see that the properties of the clay was drastically changed. And those results, if you are interested, you can read this paper, Sustainable Ground Improvement of Soft Clay Using Eggshell Lime and Rice as Cash. So first we tried to add only eggshell lime with clay, because clay contains silica and alumina, and the lime can react with silica which is available in clay. Now if you wait for this pozzolanic reaction to happen, we could see that the almost 5 times improvement in strength was observed. Now, why rice as cash? Rice as cash is also another waste product from the paddy field, right? From the agricultural waste. So this rice as cash contains silica. So if you are expecting more strength, that is, you are making use of silica from clay and Ca2 plus from lime. Now, if you need more reaction to happen, you can add rice as cash. That is, it will contribute more silica for the reaction, and then you can add more eggshell lime. So we could see that in the case of lime, because there is a limit for the reactive silica which is contained in the clay, there is an optimum value of about 3%. But if you supplement more and more rice as cash, that is, if you supplement more and more silica, and then if you add more content of eggshell lime, you could see that the strength is drastically increased. So that was found to be a sustainable option to replace conventional lime for the soft soil stabilization that can be used in majority of the sites in Kerala for the subsoil improvement. That is, we can replace with lime, replace lime and cement. So we can consider this as a sustainable option because it recycles the waste material, reduce the landfill contributions, and also this is a renewable alternative to the traditional lime source, because traditionally we are extracting lime from the limestone. Now, another important aspect is this is an eco-friendly solution. Of course, in the calcination, we do need energy. And if we are making use of some renewable energy for a calcination purpose, then that can be taken care of. Other than that, you need additional energy for the mining and processing of the limestone, which you can save in this case. And the land depletion because of the mining operation. So that can also be saved in this case. And this is going to be cost effective because you are lowering the raw material cost and the purity. Most of the time, the limestone derived lime will have some impurities, and we could see that eggshell lime has a minimum impurities in it. So because of this high impurity, the reaction is also going to be more superior in this case. Now, another approach was to utilize this eggshell lime, in combination with RHA to increase the strength of sand. Sand means it's a, we all know the river sand, right? So the sand, you know that it doesn't have any cohesion. You can't mold it into any shape. It's not plastic. But sometimes when we need more strength, we use cement columns to improve the strength of the sand. So here what we did is we tried to use this eggshell lime plus RHA. We introduced this material into the sand, and we could see that when we mix up with water, which is already there in the ground by means of the groundwater table, so we could see that it's binding the sand material. You can see the first photo is showing the raw ingredients, sand, RHA, and the eggshell lime, and the second photo is showing the mixed material, and then a third photo is showing the binding property of this material. So we could see that when we tested this material, the strength was drastically improved. So the test results are all available in this paper, and this can be used for improving the load carrying capacity of the sand. So if you have a loose sand deposit at a particular site, and if you want to improve the strength, instead of making cement, you can make use of this technology. Now, another important area which requires our attention is the waste management. Okay, in most of the places in, not only in Kerala, if you see any place in India, any major cities, if you consider, most of the cities will have one waste dump. I'm not calling it as landfill. It's mainly waste dump. That is, if whatever waste you have is just dumped on one particular site. And here what you see is, in the year 2016, in the Honor dumping ground, it caught fire in Mumbai. And this happened, I visited this place. This is the time when I was doing my PhD at IIT Bombay. And there were many waste dumps like this. And most of the time, you'll not be able to see anything around because of the fire and the thick smoke which cover the area. And this is a photo which I have taken from Chennai. It's not only the case in Chennai, most of the places in Kerala also you can see this kind of a site. That is, the waste is dumped on the service road, and because of this burning of the waste along the roadside, it's very difficult, especially for the two-wheelers. It's very difficult to drive, and also it is creating a lot of health and environmental issues, and it emits toxic gas, as we know, right? And this is a photo from Ghazipur landfill in Delhi, and this is a photo from 2017, and I think few months before, in April, it caught fire again. Okay, so I visited this particular site in the year 2017. That time it was almost, I think, 55-meter height. And now at present, if I'm not wrong, I think it's of about 65-meter height. So we do have lots of waste dumps like this, right? And also a portion of this particular landfill, I don't want to call it as a landfill, it's a waste dump. And there was a major slip, which killed, I think, 2 people, yeah. And this is a photo from Balswa landfill. So there are, I think, 3 major waste dumps in Delhi. And, it consumes almost 40 acres of land. That is just because of the waste dump, and it's the middle of the city. And there are frequent fire because of the excessive release of methane, this in MSW, there is, because of the decomposition of this waste matter, there will be methane emission, greenhouse gas emission, carbon dioxide and methane are the major contributors. And again, this is a picture from Balswa landfill. And there are many people who are living in and around that area. I think around 6,000 people are living around, if I'm not wrong. So this is a photo of old Gorai landfill in Mumbai. This is taken before capping, and recently, not very recently, I think this photo I have taken in the year 2012, if I'm not wrong. And this is after capping. So it looks very beautiful because, the top is covered with a geomembrane, and then a greenery is given. So I could not find any option for, gas extraction. It was flaring out, and there was no bottom liners because that was an existing dump. And What I mean to say is, like, we had Swachh Bharat mission in 2014, and it's the year of 2024. Of course, there are a lot of, initiative from the government side to improve the conditions. There, afterwards, there are many landfills which has come out, but I don't feel like, 100% we were able to achieve the Swachh Bharat mission. Whatever was the objective could not meet. But there are many initiatives. After that, there were many landfills, and there were many waste to energy plants. There were many, recycling plants. But still, I think we have a long way to go, because I personally feel that the Swachh Bharat Abhiyan is yet to reach many areas of the country. So what we don't need any open waste dump. What we need is engineered landfill. And landfill is, I'm not talking landfill as a sustainable option. That should be the last option, because from the waste we should look into, how much we can reuse, and then the recycle, and then the energy recovery. So afterwards, of course, there will be some quantity of the waste which should go to the landfills. And you must be knowing that the landfill accounts for about 12% of global methane emissions. Okay, so now what should be like, okay, now in the engineered landfill, what should be our approach? So the landfill typically, I'm talking about engineered landfill, not the waste dump. Engineered landfill has several layers at the bottom, sides, and on the top. So the purpose is to, isolate the waste material from the surrounding environment. So how can we isolate this material? So for that, we should have, this is a cross section. So this is a cross section of this landfill, what I have shown here. So here, if you see in this cross section, you can see there are several layers. So if we see the top portion here, this is a, first one is gas collection and control system. Why? Because when we are isolating this waste material, there will be degradation of this waste material, and then there will be, huge gas emission, carbon dioxide and methane. You know that the methane, if you are able to capture, and it can be used as a fuel for the combustion engine or for the gas turbine for the generation of electricity. So this gas, instead of flaring into the atmosphere, that can be captured from the landfill and can be used as a sustainable option for the energy recovery. And then we do have the topsoil. The purpose of topsoil is to promote vegetation. The vegetation is actually, that's not only for the aesthetics, because in this landfill covers for several hectares of area, and then you do have, slopes on all the sides. And the slope stability is a major concern in this case. So the vegetation will take roots, and this roots will help in stabilizing the soil locally, not a deep-seated failure I'm talking about. Superficially, it will help in preventing the erosion and also stabilize the soil. Then you do have a protection layer, drainage layer, that is, we don't want any rainwater to infiltrate into the landfill system. So as and when the rainwater is reaching this drainage layer, it is diverted laterally, and then it is taken away from this landfill. We don't want any infiltration to happen into the waste material, because it will increase the pore water pressure, technically speaking. Once the pore water pressure is increased, it will lead to the stability issues. So in order to protect the stability, we don't want any pore water pressure to develop within the landfill system. Then we do have a lining system. Lining system means usually the clay layer is used for preventing this rainwater to infiltrate into the landfill. And also this clay layer will prevent the migration of landfill gas into the atmosphere. So as a sustainable option, instead of using this huge quantity of clay, wherever, especially when clay is not available, we can use geosynthetic materials. So geosynthetic materials nowadays replace the drainage layers like sand, gravel, and geomembrane can replace clay barriers and gas drainage layers. So there we do need a isolation from the atmosphere, because we want to capture the gas which is migrating from the landfill. Without migrating into the atmosphere, it should be collected into the gas vent option. Okay, so that has to be securely collected. It should be controlled and then collected separately. So these all are called the landfill top lining system. So which include the gas collection and control system, the topsoil which will promote the vegetation, and the drainage layer which will take the rainwater to infiltrate and then take away from the landfill. That is, it will prevent the infiltration of rainwater into the landfill. That means the soil or the geosynthetic material which is used in the drainage layer should have in-plane permeability. So we should be able to design accordingly, but we should go ahead with the most sustainable option. And then at the bottom, we do have leachate collection system, because when this waste material is dumped into the landfill, because of the organic waste decomposition, there will be leachate. Leachate is the liquid which is coming from the waste material. So this leachate should not migrate into the groundwater. It should not pollute the groundwater. So that leachate should be collected through leachate collection system. So for that we can use geo pipes, which is a flexible pipe but is perforated and covered with a geotextile tube. And this leachate is collected and separately collected and then taken away from the landfill site, and it is treated and then discharged into the water bodies. And or it can be reused also. Then you do have a primary geomembrane, the purpose of which is to prevent any migration of leachate into the underlying soil layer. Just below this geomembrane, you do have soil barrier. Again, it will prevent the migration of leachate if it happens through the geomembrane. So a geomembrane plus a primary soil barrier, that is called as a composite barrier system. That means if you don't provide any geomembrane, if you don't provide any soil barrier, if you simply dump waste material into the land, it's going to pollute the groundwater bodies, nearby wells, river, right? So it is very essential to have this side lining system and bottom lining system and top lining system. Top lining system prevent the migration of landfill gas into the atmosphere, prevent the infiltration of rainwater. The side lining system and bottom lining system prevent the migration of leachate into the underground water bodies. Now, thereafter, you should have a leak detection system, and that also should be accompanied with a secondary geomembrane and barrier. Okay, so if you see this cross section, we do have several layers, several layers which are responsible for several different functions. And we do have a lot of sustainable options to design it in a sustainable manner. Though landfilling is not a sustainable option, ultimately whatever waste coming into the landfill has to go to the landfill. But then we do have these kind of several layers. Then only we can call it as a landfill. Now we should think about the energy recovery options from this landfills. So here what you see is the view of Ghazipur waste dump, not the landfill, Ghazipur waste dump. This dotted line is showing the portion which has undergone a slope failure in the year 2017 or 16, I guess. Okay, so it's just imagine 65 meters of waste which was accumulated at a particular place over a period of many years, and imagine the gas emissions from the place. Okay, and there are several families living surrounding, and this is in the middle of the city, and you can see a stream which is passing very nearby. How polluted it could be, right? So how we engineers can be of help, be it a civil engineer or mechanical engineer or whoever it is. We should think about sustainable systems, and then we should look into sustainable materials, and then green energy solutions. So these are the references which I have used in my presentation. Some of them are about the construction and demolition waste, and the remaining are of eggshell lime and ricer's cash application in the geotechnical engineering field. Thank you. So if you have any questions.
Okay. Any questions? Any questions? Okay, ma'am. Thank you, ma'am, for this wonderful session. Your session has provided a deep understanding on the various sustainable green geotechnics methods and its importance. It's left a deep impression on the attendees. Once again, thank you, ma'am.
Thank you so much, and I would like to thank Professor Dilip Lal and Professor Rajesh for inviting me for this FDP. Thank you so much.
Thank you, ma'am.
Thank you, ma'am. Thank you.
Thank you.